Last video for this section, 8.1. Alright, so we've been doing a handful of examples, just using basic integration techniques and formulas. The last few examples I'm going to give you, I'm not going to go through all the integration. I'm going to go through more of the algebra because that's where a lot of people get confused. The integration, you have your power rule that you use a lot, you have your formulas from our table 8.1, but the algebra side of it, you have to remember some of your algebra techniques, so we'll go through that. Getting right into example number 4 here. Integrate 1 over 1 minus sine x dx. Now, if I pick u sub, there's no derivative of sine x present, so that's not going to work. So what other technique can I use? This is not anything in the form of a trig identity or formula. If it was sine squared, there would actually, this would be one of your trig identities, and we'll get to that. So you want to think about what kind of math tool would help me out here. So think about it and then I'll show you. Our math tool is to multiply by the number 1. Now it's going to be a funny looking number 1, but anytime you divide something by itself, that's 1. Think of like 5 divided by 5, that's 1. In the form of, so the form of the number 1 we're going to pick is the conjugate of the denominator. So the conjugate of the denominator divided by itself is the number 1. So here's the denominator. The conjugate means that I'm going to take the sign in the middle here, the second term, and swap that sign. I'm going to change it from negative to positive. And so again, I mentioned I'm not going to go through all the integration on this. I'm just going to show you the algebra side of it. So I'm going to take this integrand, 1 over 1 minus sine x, and we are going to multiply by the number 1, okay? And the number 1 looking like the conjugate of this denominator over itself. So the conjugate means I'm going to swap that sign, so it's going to become a plus sign. And then over itself, anytime I divide something by itself, it's the number 1. Of course, other than 0 divided by 0, that's the only exception. So this is a funny looking number 1, and we're going to multiply by it. And we made this choice because of what it's going to lead to. So this is a math tool we use often. So let's go ahead and do the algebra here. I'm just going to FOIL this out really quickly and see what we come up with. Why this is going to help us integrate. On top, 1 times the numerator doesn't do much. But on bottom, you do have to FOIL or use the box method. You do have to expand this out. It's a binomial times a binomial. So 1 times 1, 1 times sine, negative sine times 1, negative sine times positive sine, sine x, so negative sine squared x, okay? And then whenever you multiply a term by its conjugate, this will always happen. These two terms will add up to 0. So if you think you're multiplying by the conjugate and these terms in the middle don't add up to 0, that's a good check. That lets you know, uh-oh, I should go backwards, maybe I messed up, because these need to add up to 0. They will add up to 0. When you multiply something by its conjugate. Then we have 1 plus sine x on top, 1 minus sine squared x on bottom. Now, still I'm thinking about the integration. Why would this even help me is the thing I'm trying to come up with. And this is going to help because of something we know from trig. So we have to substitute something we learned from trig in here. I would recommend having like trig identities, maybe a list of them, handy when you're doing integration, just so you can reference them. A lot of trig identities we don't memorize. Some of them you do, so this one might actually be one you know. Hopefully this looks kind of familiar. This is cosine squared x. And real quick, that comes from the Pythagorean identity. Sine squared x plus cosine squared x equals 1. That is the Pythagorean identity from trig. And so when you simplify this a little bit more, 1 plus sine x over cosine squared x. This is way easier to work with. Here's why. You have a fraction with 2 terms in the numerator, a single term in the denominator. You can just split up this fraction. Okay, so from here, we would just say 1 over cosine squared x plus sine x over cosine squared x. And this is pretty much way easier to do at this point. From here, you just have secant squared x, which we can integrate that pretty easily. And over here, this is going to be, if you separate this is sine over cosine, which is tangent x, times on 1 over the other cosine. I know I'm saying it, let me just write it so you see what I'm talking about. Sine x over cosine x times another cosine x. So tangent times secant, and this is also easy to integrate. So I'm not doing the integration, but I am getting you to that point where you can. So at this point, you would just go ahead and integrate that using your facts that you know about derivatives of trig functions. Go backwards and find the antiderivatives of these. So that is how you would approach something like this. Multiply by a funny looking number 1 in the form of the conjugate of the denominator. Alright, now next example, example 5. This one, again, I'm not going to go through the whole integration part of it. You're going to use the power rule here and maybe u sub. I'll show you when we get there. But basically, I want to show you the algebra side of how you would solve this. So, this one here, I could separate the numerator into 2 terms over the denominator. I'm just thinking, like, what kind of technique can I try? What kind of math tool could I use here to figure this out to make this integration easier? So we're going to figure out which math tool we need for this one. Our math tool is long division. So let me show you how to do the long division part of this with polynomials. You take your numerator, which is the dividend, it's going to go inside your division house, and the divisor, the denominator, goes outside. And then you start to ask yourself, okay, how do I get this divisor to equal this dividend? This times what equals this? And so I cover stuff up when I do this process. So I say 3x times what, and the what goes here, 3x times what equals 3x squared, and that would be an x. Once you know what to multiply by, you multiply by both terms here. So 3x times x is 3x squared, x times 2, so plus 2x. And then with all long division, the next step, just like it would be with numbers, it is with polynomials, is subtraction. So we're going to subtract 3x squared and subtract 2x. So this term becomes 0. Negative 7x, take away 2 more, that's negative 9x. We would bring something down if there was more terms in the dividend here, but there's none, so we just move on from here. So then I can ask myself again, so technically I can like bring down a 0, but we don't need to. So I would say, all right, 3x times what, the what goes here, equals negative 9x. And so what's missing there, how I get there, is a negative 3. Then I multiply. Negative 3 times 3x is negative 9x. And then negative 3 times 2 is negative 6. Now be careful, you always subtract. So even though there's already minus signs, you still subtract. So a minus and a minus becomes a plus here. Same thing here. And so when we simplify, negative 9x plus 9x is 0. And then there's an invisible 0 here, plus 6. And so this is our remainder. And we write our remainder over our divisor. So this integrand becomes x minus 3 plus, because it's positive 6, plus 6 over the divisor. And then we can integrate like this. And this is way easier. Just integrate each term individually. And you can use u sub here if you just let the denominator be u. Okay? Example 6 here. Alright, so again I'm going to show you the technique we could use to simplify this integrand to make the integration easier. Now this one, u sub is actually going to work, u substitution. You pick u, your choice of u, in order to make your integration easier, but also because the derivative is there in the integrand, and the derivative of what my choice is going to be, it's not there, but it's still going to work, and sometimes you're going to do this process. So the only real choice for you is this expression 1 plus square root x. So the derivative here with respect to x, so remember how this goes. This is the same thing, this term here is the same thing as x to the 1/2 power. You might already know this derivative really quick. I'm just going to walk you through it in case you forgot. So this derivative of 1 is 0. Derivative of x to the 1/2, bring down the power, and then subtract 1. So 1/2 minus 1 becomes negative 1/2 dx. And then this simplifies to 1 over 2x to the positive 1/2 dx, because the negative exponent brings that base back down. And then go ahead and put the radical notation back on. So 2 square root x dx is the same thing as du. I don't see this derivative here, but it's still going to work. So let's go ahead and start. I won't sub it in just yet, all of it, but you'll see what I'm going to do. So right now, I can sub what I have chosen for u, substitute. So we have, I'm going to move the dx to the back. We have quantity u cubed, okay, what we chose for u. Now the dx, let's go ahead and solve for it so we can substitute it right there. So all I'm going to do to solve for dx is I'm going to divide by this extra factor here. So I'm going to divide by 1 over 2 square root x on both sides of this equation. Okay, and then if you're dividing by a fraction, flip it and multiply, and you end up with 2 square root x, so right over here, 2 square root x times du is dx. Okay, now when I substitute that in, watch, hopefully you recognize like this doesn't look right, and I'll address that, I'll fix it. So if I substitute that in right now, this is 1 over u cubed, dx is 2 square root x du. So the issue, hopefully you see it, is that I have a mixture of u and x, and that's not going to help. I need to get rid of all the x's and put them in terms of u, or just keep all the x's and don't introduce u in the first place. But we introduced u for a reason, and then we have to just address, well, what does this really mean? What does this look like with a u, since I'm going with u as my variable? We already talked about it. We already made this decision. So way back here, we actually know what a square root x looks like in terms of u if we just do a tiny bit of solving right here. And so we have u, let me just rewrite this, u, if I take away the 1 here, minus 1 is square root x. So then I can use this substitution, just a modification of our original substitution, to replace this square root x. So this square root x, we can now rewrite it in terms of u. This integral becomes 1 over u cubed times 2 square root x is u minus 1, don't forget your parentheses, because the 2 actually distributes, du. Okay? And then let's go ahead and distribute that 2u minus 2 times this 1 over u cubed. And then the integration is way easier now. You can just separate these two terms. You can say 2u over u cubed minus 2 over u cubed. Simplify this to be 2 over u squared. And then just use your power rule. All right, so 8.1, we did it.